Yeah, dripping on back for the next ain't some. Never tell her back that I never stay running. Sipping on facts, damn, know I got stacks in the lab. Taking pictures straight for another cat. Make shit one, I never had shit. Bitch, move, make your motherfucking head split. Cost to the loss, never really don't play shit. Got me never really don't chase it. Dreams to the play, no fake. Ass to the way, niggas know I ain't play. Fast to the break when I switch all day. Stands for the plans to the damn all day. Sticking up signs, read never mind me. Point to the ground.
So hello guys, with the name of God, Ram Ram. Today we are going to solve a very interesting problem which was asked in Microsoft online coding test. Okay, as you guys know, no one else apart from me really trains for online assessment of top tech companies. I make sure I do it for my students everyday life for the 8 months. Okay, before starting this session and everything, let's congratulate our recent selection, Anurag Tiwari, who has cracked a very big SD offer from Zscaler. He was a very beginner 5 months back, but still he managed to do this. So he was just like you. He was fearing. He always used to ask me, Sir, मेरा हो तो जाएगा ना? मुझसे ओए तो निकल जाएगा ना? I always told him that if you work hard daily, surely one day you will crack. And guys, he has changed and turned his dreams into reality. So congratulations Anurag Tiwari for cracking the Zscaler online assessment as well as the interview. Okay. Also guys, congratulations to Vinit Tekwani. He has secured world rank 50 out of 25,000 people in the LeetCode DSA contest. Earlier in our mentoring community, the highest record was of 184 rank. He has got world rank 50. Now you guys have to work even harder. Do the full 800-hour course and you guys have to reach world rank top 10 because you're Kumar K student. In some days, in all the competitive programming platforms, the top rank should only be of Kumar K student. Is it clear to you people? React with emojis quick, quick, quick. Like I will tell you one joke. Like in Cisco, people were talking to each other. Okay, in Cisco, like recently many people got intern plus full time in Cisco now. So all of them are working in Cisco. Okay, so the new people when they started are talking to each other in the Cisco office, 50% of them are all my students only, and they quickly realize, अच्छा तुम वो बैच से हो, वो बैच से है, सब दोस्त बन गए. So guys, I want this only. In all the good companies, most of the students should be Kumar ke students only. Okay, I want this phenomena to occur. Clear? ठीक है. Whenever new joining happens in any company, all the half of the students should be from Kumar ke program. Okay? Yeah. Because we are doing everything in the best way. You guys have to generate the best result. Now, guys, if I directly go and show you the question, you will not understand most of the things. It was asked in Microsoft Online Assessment. So I will first make the simple concepts of graph clear for you people, okay? So if I talk about graph, what is a graph? So guys, see, it is very simple, nothing special. It is nothing but a set of nodes and edges. Set of nodes plus edges. That's it, guys. That's it. So I am giving a graph here, guys. You have to tell me how many nodes are there in this graph. Okay, I will be giving you the access to write in the chat. Guys, how many nodes are there in the graph? Start writing in the chat. 3, 2, 1, 0. Guys, everyone start writing the number of nodes which are there in this graph. 4. Correct, correct, correct. How there are 4 nodes you can see from your eyes, na? This node, this one, this one, this one. Okay, guys, how many edges are there in this graph? Can anyone please tell me? Edges means the lines connecting the nodes. How many vertical lines or how many lines are there in this graph? Edges, guys, how many edges are there? Guys, can you guys tell me which are those four? Which are those four edges? Which are those four edges? Can anyone tell me? The edge is this edge, first edge from 0 to 1. This is the second edge from 1 to 2. This is the third edge from 1 to 3. This is the fourth edge from 2 to 3. So you guys have this much understanding of graph, right? I will give you a last exercise. You just answer it for me and then guys we can move on to the actual question. Guys, in this graph, tell me how many nodes are there. We represent node by the variable n. What is the value of n? How many nodes are there? Start writing in the chat. This whole graph, this whole graph I am talking about. How many nodes are there in this graph, lovely people? Okay, six nodes are there. One, two. Node means the number of circles. One, two, three, four, five, six. Okay, six. How many edges are there? Edges is denoted by M in generally in online assessment and competitive programming problems, even in your interviews. In interviews, it is better to use the variable name edges. But just now, if I denote M with the edges, how many edges are there in this graph, guys? How is the answer 7? Oh my goodness, 161 people. Guys, we have crossed the highest amount of limit of people which have ever joined my session. Congratulations. Highest limit was 130 and today here are 160. So, great job. It means many are learning. Guys, edge, this is the first edge, second edge, third, fourth, fifth, sixth, seventh. Seven edges, okay? So, guys, that's it. Did everyone understand these basic terminologies of graph? Write yes in the chat so I can understand that you, I can assume that you guys have this much idea. Okay, okay, good, great, nice. At the end of the session I will give you the premium warm-up course for free, so stay in the session till the end. So guys, these things are clear to you. Very nice. Guys, I just wanted to check, do you know what is a queue? Because that is needed na. Queue is nothing but a simple data structure which stores some elements. Okay, so this is my queue. Okay, this is my queue. Let's say some elements are there in the queue. Okay, 5, 4, 3, 2, 1. Okay, okay, this is my queue. This is the front part of the queue. This is the back part of the queue. Okay, so guys, if in a normal queue I try to push 8, I try to push 8, how will this queue look like? Where will the 8 go? Will the 8 go at the back or will it go at the front? I'm just revising your basic DSA concepts. Everyone right? No, Aman, wrong. Aman Sheikh, you are incorrect. It doesn't go at the front. It goes at the back, guys. General queue terminology, it always goes at the back. So, guys, if you push an element, it will go at the back. How will the queue look like, guys? Write in the chat. After you push 8, how will it look like? It can only allow to go at the back for a normal queue. Guys, it will look like this. Guys, you understood na? React with emoji. If I do a push, the number goes at the back. Clear na? Okay, lovely people. Guys, I'm giving you one more example. Please tell me how the queue will look like, okay? I do a push of 5, then I do a push of 1. If I first push 5, then push 1, how will the final queue look like? This is your DSA assignment. Please tell me, lovely people. How will your final queue look like? If you push a 5, then you push a 1. First you push a 5, so 5 will come at the back. Then you push a 1, 1 will come at the back. Okay, guys. Queue has a front operation also. Front means it will print the frontmost element, okay, with the element which is at the start. So, if I take the old queue, guys, and I do the queue dot front operation, which number will get printed for this queue 54231 if I do the front operation? And guys, if I do the pop operation, what will happen? Pop means removing the front element. In the queue, you can push the elements at the back or you can remove the elements from the front. If you do the pop operation, 5 will be removed. So guys, write yes in the chat if I can assume the graph and the basic queue knowledge is clear to all the 150 people in the meeting, 150 plus. There are 154 actually. Guys, clear now? Yeah, love you all. Great. Finally, because you guys know these concepts, I can start the Microsoft online assessment. Ready, guys? Let's start. Guys, this is the link to the question, by the way. So I am giving it to you guys. Just keep it with you handy, okay? It's a very nice one. Because we have to solve these questions now. We have to become strong for FANG companies online assessment. So guys, you have this link. Very good. Great. So guys, you are given an undirected graph consisting of n vertices numbered from 0 to n minus 1 connected with m edges. The graph is described by two arrays a and b, both of length m. Okay, a pair a of k comma b of k for k from 0 to m minus 1 describes an edge between vertex a of k and vertex b of k. Each second, every vertex with at most one edge connected to it disappears. Every edge which is connected to one of the disappearing vertices also disappears. After how many seconds will the vertices stop disappearing? Now, let's make the understanding of the problem clear. Okay, most of the people will not even understand by reading that. So guys, I have given you the link. Please start opening it. Yes, the simulation is simple, but you have to do it in an efficient manner, Sequeline, or else you will get TLE. So guys, start opening the document which is given to you. Yes, Chenmai, yes, you are correct. Guys, open the link now and write yes in the chat if you are able to open the link. If you don't open this document, how will you attend the session, right? So this document you should open. Okay, clear? Clear na? Okay. Now let me clear up the meaning of the problem, understanding of the problem of Microsoft Online Assessment. Okay, so understanding, guys, understanding is pretty clear. You are given a graph. You are given a graph. You are given a graph. Whichever node has one or zero edge connected to it, you have to destroy that node. You have to destroy that node. Keep doing this each second. Finally tell how many seconds it takes to do this process, guys, to do this process. So guys, the thing is that you are given a graph, you know that, you are so happy. Whichever node has one or zero edge, you have to destroy that node, and all those edges will also get destroyed, by the way. You keep doing this each freaking second. Finally tell how many seconds it will take to do this process. So guys, let's take a brilliant example here. This is the graph, right? This is the graph. So let me write 645 120, 645 120, 6 4 5 1 2 0. Guys, this is the graph given to you at t equal to 1 second. In the first second, guys, you have to destroy all nodes. Destroy all nodes which have only 0 or 1 edges attached to them. Okay, so guys, which are the nodes which has only 1 edge or 0 edge connected to them? I am going to open the chat. You have to tell me, lovely people, in this graph, which are those nodes which is having only 1 edge or 0 edge connected to them. 3 2 1 0. Everyone start writing in the chat fast. Which are those nodes in this graph which has only 1 edge or 0 edge? Let me see the answers of the people. Everyone is writing 356. Someone is writing 65. Guys, 653356 is the correct answer. Does everyone understand why 356 is the correct answer? See, 3 is lonely. 0 edge, no edge is connected. So 3 is a valid node to be destroyed. 5 is also valid. Why? Because 5 is connected to only one guy. Either your node should be connected to 0 guy or 1 guy. Then only you are allowed to destroy it in that particular second. 6 is also connected to only one guy. So 6 is also valid. So who will get destroyed? 3, 5, 6. So at t equal to 1, 3, 5, 6 will get destroyed. So guys, how will the graph look like if I destroy 3, 5 and 6? Destroy this, destroy this, destroy this. Let me make the new graph. 4, 1, 2, 0. So guys, I did what I had to do at t equal to 1. Now the time is changing. T equal to 2. Guys, which are the nodes in this new graph which is having only 0 edge or 1 edge? Giving you guys some time. Write in that chat, guys. Write in the chat fast. Which is that node which only has 0 edge or 1 edge in the graph? Yeah. Okay. Okay. That node is nothing but node number 4. Okay. Why, guys? Because 4 is connected to only 1. So 4 will be destroyed. So, guys, do you understand? Everyone write yes in the chat. Who got destroyed at t equal to 1? At t equal to 1, 3, 6, 5, all were having 0 or 1 edges. It got destroyed. At t equal to 2, 4 got destroyed. Okay. Now, guys, after 4 gets destroyed, how will your graph look like? 4 destroyed. 1 to 0. 1 to 0. So, guys, at t equal to 3, which are the nodes in this graph which is having only 1 or 0 edge? Let's see the IQ level of the students. Which node in this final graph has only 0 or 1 edges, guys? No, 3 is wrong. None. No, Ashish. 2 has 2 edges. This also has 2 edges. This also has 2 edges. None of the nodes can be destroyed. Everyone write in the chat at t equal to 3 none of the nodes can be destroyed. Write something like that. T equal to 3 no one can be destroyed. So you understand this concept, guys. Guys, it is clear to all people now, none can be destroyed. So, guys, you were able to do this process at till which t? Till which t were you able to do this process? You were able to do it till, see, t equal to 1. You did it. T equal to 2. You did it. T equal to 3. Not possible. So answer is t equal to 2. The last second till you can destroy. So output is what? 2. 2 is the output. You guys can see it is written here. For this graph which I am discussing, uh, all 3 remaining vertices will remain connected to 2 edges. None will disappear. Answer is 2. Okay. You can see many different examples here. Okay. For example, see this nice graph, square graph. None of the edges can ever be destroyed. You can take this example also, 0, 1, 2, 3, 4, 5, 6. Okay, so guys, let's discuss one last example and then we are done. 0, 1, 2, 3, 4, 5, 6. Guys, you only have to tell me at t equal to 1 who will get destroyed. Right in the chat, guys. Nana, please tell me at t equal to 1 who will get destroyed. Okay. Yeah, I am showing you the example. You don't need to worry. Don't need to worry. I'm showing you the example, lovely people. So, I will show you. This is your example. So, all the nodes in this graph which is having 0 edge or 1 edge. This is the guy. This is lonely. Let's call them lonely. Who is lonely? 0, 3, 4. Only having 1 edge will destroy it. So, 0, 3, 4, 6 will be destroyed. 0, 3, 4, 6 will be destroyed. Then how will the new graph look like? 1 connected to 2 and 5. Guys, at t equal to 2, who will get destroyed? See, 5 is also lonely now. And 1 and 2 also lonely. So all 3 will be destroyed. In first second, 0, 3, 4, 6 will be destroyed. In second, 1, 2 and 5 will be destroyed. In 2 seconds, full graph gets destroyed. 2 is the answer in this case. And guys, if nothing can be destroyed, then you write it as t equal to 0, by the way. Okay. For example, in this case, it will return 0 because from the start only you cannot do anything. Okay, guys, now I will move towards the analysis and solution. Right now, till now, I was only explaining you the meaning of the question. Is it clear to all the 150 people in the meeting? The understanding of the problem clear till the full end? All example clear? Okay, great. Awesome. Nice. The nice thing about this problem is that you don't need even BFS, DFS knowledge, okay? You just need little bit of sense, okay? Yeah. Yes, Chinmay, something like that, Chinmay. But here you have to do level order traversal BFS, okay? Like queue inside queue, you have to use multiple queue in this problem because at each second, multiple nodes can be removed. So, guys, what is the first basic organic observation which you can do? I can also do and you can also do. I'm quickly writing it for you people. Organic observation. That organic observation is that organic observation is it's common sense that make adjacency list of the graph. You will have to store the graph in a data structure, na? So store it in the adjacency list, okay? I assume you know this thing. If you don't know, I will give you some prerequisite videos. Make sure to watch. Then directly attack the nodes which are having degree equal to 0 or 1. Guys, everyone react with emojis if you agree with me that yes, sir. First, we should directly start attacking the node which is having a 0 degree or 1 degree. 0 degree, 1 degree means 0 edge or 1 edge connection. Guys, this is common sense for you, na, that you should first attack the 0 edge and 1 edge, guys. Okay, nodes which are having 0 edge or 1 edge. So if I move towards the solution, how will the solution look like? See, what I'm going to do, like, it is common sense. Let's say I have this graph. Guys, if I store this in an adjacency list, how will my adjacency list look like? Adjacency list will be something like this, right? So 0 is connected to which nodes? 0 is connected to 1 and 2. So 0 will be, this is our adjacency list G, okay? I will call this list as G, capital G. 1 is connected to 0 and 2. 2 is connected to 0 and 1. 3 is connected to nothing. So empty. 4 is connected to 5, 6 and 1. 5, 6 and 1. And 5 is connected to 4. 6 is connected to 4. So guys, if I convert the graph into the adjacency list looks like this. Everyone in the meeting, write yes in the chat if they understood how I converted the graph into the adjacency list, and be quick about it and react with emoji. Clear? Okay. Okay. Clear to you people. Okay, love you. Okay. So, you guys understood that. Now, guys, I will make a D array. D array should tell me the degree of that node. Okay. So, adjacency list, you will check. Guys, two nodes are connected now. So, degree of node 0 is what? 2. Degree of node 1 is what? Degree of node 1 is also 2. Okay. Degree of node 1 is 2. Degree of node 2, basically two edges are attached. 2. Degree of node 3, 0. Degree of node 4, 3. Okay. And degree of node 5, 1. Degree of node 6, 1. Why? This is nothing but the number of elements. See here, there are two elements, so I wrote degree of node 0, 2. 2 here, 2 here. Two elements here, 2 here. No element, 0. Degree of node 4, 3. 3 elements are attached to 4. Degree of node 5, only one element. So D of 5, 1. D of 6, 1. Everyone write yes in the chat if they understood how I created the degree array of each node. I'm just checking how many elements are directly connected from the adjacency list, and I'm writing the number. Clear? Common sense, na? Okay. Degree of 1 is 3. Okay, sorry if I made a mistake. I will check degree of 1. Yes, guys, 4 is also attached. So thank you. I'm writing that. Guys, 4 is also attached to 1. So degree of 1 is 3. Okay. Thank you for pointing it out. So guys, this much is clear to you people, right? Clear now? Okay, great. Now, listen to me carefully. I am having degree of all the nodes, right? All the nodes degree I am having, okay? Now what I will do now, I will take push all the nodes in a queue which are having the degree as 0 or 1. Can anyone tell me why Kumar K sir is only focusing on the nodes which are having degree 0 and 1? Write the reason in the chat. Why am I only selecting those nodes which will be having degree 0 and 1? Common sense. In the question it is written that first you have to attack the node which is having degree 0 or 1. Common sense. Clear? Common sense is clear? Okay. Coding is mostly common sense. So guys, which are the nodes which are having degree 0 or 1? No, d of 0 is not 0 or 1. Basically, the degree should be less than equal to 1. Then it will be 0 or 1. D of 1 is also not 0 or 1. D of 2, not. D of 3 is 0. D of 5 is 1. D of 6 is 1. So, in my queue, I will push 3, 5 and 6. Why? Because D of 3, D of 5 and D of 6, all three of these are less than equal to 1. They are either 1 or 0. Either 1 or 0. In my queue, I have pushed these guys. I have pushed these guys. Lovely people. Write yes in the chat if everyone understood this, that Kumar K sir pushed that. Okay. So, Sequilin. Oh, my lovely student Sequilin. Listen to me. Sequilin, please tell me. Now you have pushed this 3, 5, 6 in your queue. Now what will you do? You guys use your own brain and tell me. You are Kumar के स्टूडेंट सो यू आर गॉड गिफ्टेड ओनली गॉड गिफ्टेड पीपल कम टू मी नहीं तो तुमको लगता है रोज इतने सिलेक्शन हो जाते तुमको हलवा लगता है ये सब नहीं आई एम वेरी लकी ओनली गॉड गिफ्टेड पीपल कमिंग टू मी normal average people don't come to me. So guys, 356, you're god gifted. Tell me, what will you do? Print all of them. Simple. Print all of them. Print 3, 5 and 6 and write their time t equal to 1 because all of them are having 0 and 1 na, and remove them from your queue. Queue has become empty. So this is the common sense. 3, 5, 6 are having 0 and 1. You print all of them from the queue and you write their timing as 1. That's it. That's it. That's it. But guys, we have to update the degree of other nodes. Na? We have to update the degree of other nodes also. I will show it to you via live example. Okay. So, let's say guys, I had a 4 year, had a 1 year, had a 0 year, had a 2 year, had a 3 year, had a 5 year, had a 6 year. Okay. So now what am I doing? I am deleting these nodes, right? So I am deleting this. I am deleting this. I am deleting this. But guys, when I delete these nodes, which is the node whose degree is getting affected? Please tell me in the chat, guys. Which is that node whose degree is getting affected? So, आप ही बताओ. Will you kick out 3, 5 and 6 just like that, or will you do something with them and then you will kick them out? Think about it. Will you directly kick them out? Will you directly kick them out? Right? Yes or no in the chat. For example, you have a friend, okay? He gives you a very tight slap in front of your crush. Gives you a very tight slap in front of your crush. Obviously, you will block him and you will delete your friendship with him. But is that much enough, guys? Is just cutting the friendship enough? Or do you have to give some reaction there? Use your brain. You also have to give return slap. So, here, you are removing 356, but whoever is attached to 356, okay, 3 no one is attached, this 4 is attached to 3, reduce its degree by 1. Earlier d of 4 was 3 na, d of 4 was 3, but if you remove this 6, d of 4 will become 2. Once you remove this 5, one more edge is gone, d of 4 will become 1. Now only one edge is there for d of 4. So remove the nodes with mindfulness. Okay. So how will I remove that? I will show it to you. Okay. So let's say I have this 3, 5 and 6. Okay. So when I'm trying to remove 3 of this queue na, from the let's say 3, 5, let's say it's 5, 6 and 3. Okay. So let's say the front guy you will try to remove 5, right? So when I'm trying to remove 5 na, I will run a for loop. That for loop will iterate through all the nodes directly connected to phi. How will I know which are the nodes directly connected to phi? Why are you worrying? You in the adjacency list that data is stored. Who is directly connected to phi? 4 is directly connected to phi. It was written there. So you will run a for loop for all the nodes which are directly connected to phi. Okay. So whichever node is directly connected to phi, what you will do? D of u equal to D of u minus 1. Why? Because this 5, let's say it is connected to 4. So if you are decreasing it, so this u is 4. So D of 4 equal to D of 4 minus 1 should happen. Whoever is connected to me should face the problem. The degree should decrease by 1. I will show a live example to you guys. Let's look at here. Guys, if I am removing phi, please tell me whose degree is going to get affected. Write in the chat, guys. Write in the chat. Quickly start writing in the chat, guys. 8 and 10. So I will run a for loop. For loop for connected nodes of 5. In C++, Java, Python, you can do this. So 8 will come and 10 will come. What you will do? D of 8 equal to D of 8 minus 1 and D of 10 equal to D of 10 minus 1. And the frequencies will and the degrees will be updated. Okay. So in our past case, what is going to happen? So 3 was here, it got destroyed. 5 was here, 6 was here, it got destroyed. 5 was here, it got destroyed. So while doing all this, you will come to know that the degree of 4 has become what, guys, now? Please tell me. What is now the updated degree of the node number 4? So when you find out that some guy has become 1, what will you do? Use your brain and tell me. Now you find out one more guy has become 1. Whoever becomes 1, push it into the new queue. Earlier queue was there, na? Let's say you create another queue now. Again, push 4 into it and the same algorithm will run again. Queue will only have the nodes whose degree is 0 or 1. So now 4 comes again. 4, this guy comes again. What will you do? You will print 4 and you will say the timing is 2. Now what you will do? Update the degree of all the nodes directly connected to 4. So guys, who is directly connected to 4? This guy. This 1 is directly connected to 4. Now its degree will become from 3 to 2. So it will be like this. It will be like this, guys. 1, 0, 2. And guys, that's it. It's so easy. It's so easy. Phenomenally easy. Okay. So that's all you have to do. Its degree will be updated as D of 1 equal to 2. But now, when you update the degree, now, the nice thing is that all are 2. So you will never have a chance to put any other node in the queue. So when you have no option, you will stop the algorithm. Basically, when you don't have any element to put in the queue, you will stop your algorithm. Okay, guys, there is one more nice thing about this algorithm. What is the nice thing? You don't have to search at each iteration which are the nodes having the degree 0. Only first time you have to search. From the next time, you never have to do this searching. Can you guys tell me why? For example, चलो मैं आपको I will bring feelings in you. Have feelings for the question, not for your crush. Have the feeling for you the question. Okay. So guys, let's say I'm giving you this degree array. Okay. I don't even need to imagine the graph. Let's say the degrees are like this. Okay. So guys, everyone write yes in the chat if they can imagine this degree array. Let's forget about the graph. This is a degree array. Okay. What will you do to find the nodes which are having 0 and 1? You will run a for loop from here to here. It will take O of n time for the first time. So node 3, 2, 3, 4. Okay, you did this. Now the nice thing is that these nodes, when you remove them, they will decrease the degree of other nodes. Because you are updating it yourself, na? You will exactly come to know when it is becoming 0. So you don't need to again and again travel the whole array. अरे तुम खुद ही d of u minus 1 कर रहे हो ना. खुद ही डिग्री को कम कर रहे हो ना, तो जब वो जीरो होगा तो तुमको तुम्हारी आंखों के सामने दिख जाएगा. I will give you a brilliant example for this. For your semester exam, you did not study in engineering drawing exam, okay? ED. When you go to the exam, you see कि you solve, तुमने सिर्फ ये क्वेश्चन करा, ये क्वेश्चन करा, ये क्वेश्चन करा, और कट ऑफ था 35, और लास्ट के 5 मिनट में तुम कर रहे हो 25 मार्क वाले टोटल क्वेश्चन. देख के पता चल जाता है ना कि फेल हो गए हो, या रिजल्ट का वेट करने का टाइम लगता है. टेल मी इन द चैट गाइस, does it take time to you to understand? No, you know you have failed because passing was 35. You wrote only 25 marks. Do you guys know, even I got KT, even I failed engineering drawing. That is the only exam I ever failed in my life. My drawing skills are, I'm not able to visualize the drawing stuff. Okay, so I did fail it in first year of engineering. So what happened is that the exam, I don't remember, it was 100 marks and 35 was the passing mark. I was very weak at this and I exactly solved 35 marks question. So मुझे पता चल गया इसमें मुझे फुल तो आने नहीं वाला. So try to understand. When you are becoming zero, you will know. You will be updated about it at that time only. You don't need to check the whole array. You will automatically come to know. You do d of degree -1, just check. Has it become zero? If it has become zero, push it into the new queue. That's it, guys. That's it. Clear? Okay, guys. Everyone write yes in the chat if the algorithm is clear. If any doubt, please ask me. What I am doing nothing special. I am just checking who is having 0101 degree. I am pushing them in my queue. I print them, and then whichever nodes are connected to them, I just update their degree. And I see if anyone has become zero, I again push it to the queue. I do this again and again, again and again, again and again, till my job is done. Clear? Yes. Now, guys, I have the Java, Python. I have all the codes for you people. But for this session, I don't want to like stretch it very long. So let's try to understand with this the C++ code. Okay. So, guys, if you guys have this document, you will understand. Let me write here some observations quickly. C++ code. Okay. Others will be updated after the session is done. Uh, okay. What was the thing? Push those nodes in the queue. Push those nodes in the queue. Push those nodes in the queue. Now, pop all of them, and their timing will be the current t. Okay. When you uh, pop out some node, make sure you update the degree of all other directly attached nodes and decrease it by 1 if you find it to become less than equal to 1, if you find it to become less than equal to 1, then push it into the new queue. Okay, so that, guys, that's it. Okay. Then again, your original queue, you put the elements of new queue inside it. Okay. So, guys, if I directly try to check the code, I will explain you what are we trying to do. Okay. Yes, guys, I have given the document link. Okay, guys, now please look at the code. Okay. I want a yes from everyone, if they understand the code or not, because, guys, I'm putting all my effort to make you understand. So you guys should also let me know if you're understanding. Lovely people, this is the your code, C++. So, guys, you can see n number of nodes, m is the number of edges, a of n and b of n I'm using to take the input of the edges. Okay, so a of I read from 0 to m minus 1, b of I read from 0 to m minus 1. Guys, I'm making a graph adjacency list, now. G of x dot pushback y, g of y dot pushback x. You guys know this thing now, how to make a graph. If there is a edge in our question, it is given that there is a edge from x to y. If there is a edge from x to y, if there is a edge, there is an edge from x to y. That's why g of x dot pushback y. This will make sure that in the adjacency list after x, here y should be written. And g of y dot pushback x, this means that when y is written in the adjacency list, it will be directly connected to x like this. So these all elements are a of I, these are all b of I. So react with emoji if you understood what is happening here. G of a of I dot pushback b of I, G of b of I dot pushback a of I. Clear, guys? Lovely people, clear? Okay, great. Next thing, guys, I am going through each node from 0 to n minus 1. How many nodes are directly connected to that node is nothing but G of I dot size. Size of the adjacency list, na? What is the size? What is the G of 0 dot size? G of 0 dot size is nothing but the size of 0, which is 2 elements. So D of 0 equal to 2. What is the size of 1? What is the G of 1 dot size? G of 1 dot size means the elements directly connected to 1. One element is connected. So 1. So I'm writing all the degrees. See, int V equal to G of I dot size. Okay, I got the size. I write D of I equal to V. Means the degree has been updated of the node I. If that degree is less than equal to 1, guys, push it into the lovely queue. Get your job done. And guys, this node has been used now. So used of I equal to 1. Okay, great. Guys, I by mistakenly wrote this extra for loop. You please delete it. Okay, it has no use significance. I was testing my code. So line number 32 to 35 is redundant. All react with emoji in this meeting if they understand line number 32 to 35 is redundant. I just used it for testing. You can delete it in your code. Okay. Okay, lovely people. So I'm sending it here also. I will make you the best coder. Don't worry. And guys, stay till the end of the session if you want the premium course. Okay, for free. So guys, now next thing, guys. See, now I have written the code with lots of brilliancy. You will see that Kumar K sir has putting two while loops and one for loop inside. So see, use your common sense and tell me your algorithm should when should your algorithm stop? Your algorithm should stop when your queue has no elements, zero elements, right? So u is storing the size of the queue. I have stored the elements which are having 0 and 1 degree. If u is greater than equal to 1, it means elements are inside the queue. Then don't do anything. But if there is no element in the queue, if u is 0, then I set my g as 1. So while g equal to 0 means while the queue is having some elements having some elements which are having 0 degree or 1 degree, the algorithm will keep on continuing. The day it does not has anything, it will be updated to 1. You can see in the end also I'm updating it again and again. Whichever updated queue I got now, I'm checking its size. Lol equal to q dot size. If its size becomes 0, I update my g as 1 and my algorithm will stop. Algorithm will only run if g is 0. G is 0 only if q has some elements. Everyone react with emoji in the meeting if they understand that algorithm is only running if g is 0 and q is having some elements to process. When will q have some elements to process? It will only process the elements which are having degree 0 or 1. If it is not there, it will stop. Now guys, next thing. I am creating a new queue. Okay, I do have an old queue which has all the elements 0, 1, but new queue, there is a purpose I will explain later on. Okay, so guys, let's say my queue has 3, 5, 6 now, right? My queue has 3, 5, 6. So lovely people, I print those guys that hey 3, 5, 6. I also remove them from my queue. Okay, now whichever element I'm removing now, I'm going through all the neighboring nodes of it directly attached, loop. जैसे कि समझो आप 5 को निकाल रहे हो, you are removing 5 and 5 is directly attached to 8, 10 and 11. Okay, so what will happen is 5 o is nothing but 5, you remove o. Okay, but now I'm going through all the nodes which are directly attached to o 5. So 5, 8 and 5 is my o and the directly attached nodes are y. So y is 8, 10, 11. So d of 8 will be reduced by minus 1, degree will be reduced by minus 1. D of 10 will be reduced by minus 1. D of 11 will be reduced by minus 1. Guys, while doing this process, if you find out that those guys also have, if their d value has become less than equal to 1 and they have never been used before by our algorithm, I will push it in the new queue. I will push it and I will update my used as y is 1. So once all this removing is done, what I do is I update my old queue equal to new queue. So new queue I was using for that only. But guys, why I am using new queue? Because I want this old queue to get empty. If I remove an element and I again push back the element, the old queue will never get empty and you will never get the correct process of measuring the time. वाट लग जाएगी. समझाता हूँ ध्यान से देखो. ये आपका क्यू है, A356 है, ओके. अब आप क्या कर रहे हो? You are removing this and you are saying I removed 3, t equal to 1. Okay. Now you are saying okay, I removed 5, t equal to 1. But when you remove 5, you come to know that 4 का degree कम हुआ है. Let's say you push a 4 now because 4 is having also degree 0 1. You remove 6, you say t equal to 1. You remove 4, you say t equal to 1. अरे गलत हो गया ना. If you keep only a single q, you will not be able to differentiate the timings. If I keep a 2q, okay, new q and this q, now see the benefit. You know all the elements in this queue will have the same time. So you remove 3, t equal to 1. You remove 5, t equal to 1. You remove 6, t equal to 1. But while doing this, you come to know that 4 has also become an eligible node. But you put 4 in the new queue. Now, once this queue has become empty, I will now travel the new queue and I will give that all the nodes timing in the new queue as t equal to 2. This is helping us differentiate the timings, guys. That's why using two queues brilliantly solves this problem very nicely. React with emojis if you understand why Kumar Kesar is using two queues so that the time can be differentiated. पता चलना चाहिए ना कौन से नोड कौन से टाइम में आ रहे थे. सबको थोड़ी ना मिक्स कर देंगे. Clear? Okay, so guys, once in the old queue you remove all the elements, whichever are the eligible elements going to the new queue. Whatever process happened here, it took the time, not C is the time. So at each iteration, you will increase the time by 1. And whatever elements you got in the old queue, new queue, you push it now in the old queue, which has become empty, by the way. So guys, that's it. Okay, now if I talk about the time and space complexity, so amortized I will have to say because it is O of n plus n, number of nodes plus number of edges, okay. And the space complexity is okay, so the space complexity, right? So guys, the space complexity, let's check. That is also O of n plus m. Now guys, I will explain you why is the time complexity is like this. It is very important, okay. So see guys, you can see that in the new queue and the old queue, na, you are pushing each element one time only and removing also one time only. This queue, all the elements will be get pushing n times in this whole algorithm, and the new queue also, all the elements at max will get pushed n times. They will be removed also n times only, and here when you are transferring it to queue again n times. So basically you can say that it is taking 2n kind of operations, right? Pushing, removing, pushing, removing. React with emoji if the 2n is clear to you people, because time space complexity analysis, for example, you, let's say you pass this OA and you get the interview. Maybe you copied the question. So how will Microsoft interview detect you? He will ask you to explain the time and space complexity. And you will not be able to explain. Why? वो आपको मुंह पे बोल देगा, अरे यहाँ पर तो इतने सारे नेस्टेड वाइल और फॉर लूप्स है, n प्लस m कैसे हो सकता है, और आपका मुंह बंद हो जाएगा क्योंकि आपने छापा था. So you need to understand time and space complexity concept deeply, okay, so that you remain safe in all the conditions, all the situations. So now understand. You have to tell that, sir, I am looking at the amortized time complexity. I am counting all the number of operations rather than just looking at the loops. If I count all the number of operations, sir, I can see that each node is getting printed one time in worst case and getting inserted one time in the worst case, combining both the queues. So 2n it should take for that time, okay. One more thing you have to say that for each node, I can see, sir, that I am running a for loop to check all its connected node. So guys, for each node, how many iterations of for loop can happen? Let's say this is 0 node, this is 1 node, this is 2 node, okay. This, if you run a for loop on its connected nodes, there will be three edges. So three here, three edges, three here, three edges, three here. Total 3 plus 3 plus 3, 9. So guys, that for loop of iterating the connected nodes is nothing but the number of edges. So O of m time will be taken for that, right? O of m time will be taken for that. So 2n for that. And you can say m for that. And 2 is a constant. So I remove it. So it becomes O of n plus m time complexity, sir. If you explain it like that, your interviewer will surely be impressed and will select you. By the way, we have two Microsoft selections, okay? Five are the people who have not declared publicly. One is Rashi Bhave, you guys already know, and second is Microsoft off-campus intern plus selection of Sejal Agarwal. I'm thinking of making the post in March because March will be a hot month, okay? Atlassian selection also we have of Anusha Yeram. All both are off campus. Both of the girls did it off campus. Anyways, guys, so you understood the time and space. Now, space complexity n plus my. That is also common sense. Adjacency list will take n plus m space. Okay, number of nodes plus number of edges. This queue will also take n space. So more n. But if you add a n, that remains constant. The constant is only increasing 2n, 3n. Okay, and the used array of n size. So space is something like 4 into n plus m. But 4 is a constant, you can ignore it and you can say n plus m. Okay, so guys, that's it. And the Java and Python are going to be uploaded very shortly after this session is done. Okay, so now let me stop and save the recording for you people. Guys, react with emojis if most of you people understood whatever I told them.